Hello everyone. I'm going to do a couple more examples of verifying trig identities. Now a couple things just to remember when we're doing this. One is that one side of our equation is going to stay the same throughout the entire process. Normally that's going to be the side that is a little bit simpler. So that means normally we want to start with the side that is a little bit more complicated. In my example I have here, that's going to be the side that has the fraction. And then beyond that, we do have a couple methods, a couple different tools that we can use to help us out. One of those is rewriting everything in terms of sine and cosine. We also have things like our Pythagorean identities. And we also have just our basic algebraic operations that we can use as we work towards simplifying. So in this example, the tangent of x divided by the secant of x plus 1, that is equal to the cosecant of x minus the cotangent of x. So I think the left-hand side is a little bit more complicated here, just because it has a fraction. But besides just rewriting these in terms of sine and cosine, there's not a whole lot we can do with that. However, I do recognize in the denominator here, this is written in a certain form. We have an expression of our variable plus 1. So we have something plus 1. And this is a good candidate for using our conjugate in helping us simplify this. So I'm going to multiply the numerator and the denominator of this fraction by the conjugate to my denominator. So in the numerator, we're going to multiply secant of x minus 1, and then we'll do the same thing in the denominator. So multiplying top and bottom by the secant of x minus 1. And as we said, our right-hand side is going to stay the same. Now the reason we like to use a conjugate is because in the denominator, when I multiply this all out, the middle terms are going to cancel out, but we're also going to end up with a secant squared of x, which means that we should be able to use one of our Pythagorean identities. So first thing, let's distribute the tangent of x in our numerator. So tangent of x, secant of x, and then minus another tangent. And then in the denominator, so because 1 is plus, 1 is minus, this ends up being the difference of perfect squares. So we have the secant of x, or secant squared of x, minus 1. Okay. So we end up with the secant squared of x. So we should be able to use one of our Pythagorean identities. The one that I'm going to use here, the tangent squared of theta plus 1 is equal to secant squared. So that means secant squared minus 1. This whole thing is the same as the tangent squared. So we'll do the tangent of x, secant of x. So I'm just rewriting my numerator. And then my Pythagorean identity, this entire denominator, is equal to the tangent squared of x. All right, we have lots of tangents in our left-hand side here. So with this minus sign, I'm going to split this up into two separate fractions, just so I can do a little bit of simplifying. So tangent of x, secant of x, and that's over tangent squared. And in our second fraction, we'll have the tangent of x and tangent squared. Another option here is looking at the numerator. I could factor out that tangent, but we distributed it up here, so either way would work. We have one tangent in the numerator. We have two tangents in the denominator, so one of these will simplify. So that leaves us with secant of x over 1 tangent of x. Same thing in this second fraction. We have one tangent in the numerator. We have two of them in the denominator, so this will simplify to 1 over the tangent of x. And we're almost there. So now we just got to finish simplifying these. to simplify this first fraction, I'm going to rewrite these in terms of sine and cosine just so we can see what happens. So 1 over the secant, or the secant is the same as 1 over cosine of x. And then tangent we know is the same as the sine of x over the cosine of x. And that's the one that's going to be a little bit more that we have to simplify, but the second one, 1 over the tangent of x, that's just the reciprocal. And we know that the reciprocal of tangent is cotangent. Alright, and then the last thing, when I'm dividing two fractions, I can change this into multiplying by the reciprocal. So we end up with 1 over cosine of x times the cosine of x over sine of x. So taking this second fraction and then flipping it, turning that into multiplication. And then written like this, the cosines will simplify to 1, and we're just left with 1 over sine, which the reciprocal to sine is the cosecant. So we end up with the cosecant of x minus the tangent of x, which is what we're looking for. So the right-hand side of my equation, that one stayed the same the entire time, and we were just transforming our left-hand side so that it ended up matching with that right-hand side. So then if I want to justify that, yes, this is an identity, I could say by the transitive property, we know that the tangent of x divided by secant of x plus 1, we know that that is the same as the cosecant of x minus cotangent of x. Okay, let's do one more. So here we have 1 plus tangent squared divided by 1 minus tangent squared, and that's equal to 1 over 2 cosine squared minus 1. Now, both sides here, they do have fractions in them, and maybe both of them seem a little bit complicated, but when we're kind of debating between the sides, my right-hand side here is already in terms of cosine. So I think that's the side that is simpler. So I'm going to keep that one the same, and I'm going to work with this, this left-hand side. So one of the first things I notice here, and I'm going to change this right away, 1 plus the tangent squared of theta, that's one of our Pythagorean identities. So the numerator here, that's the same as the secant squared of theta. And then our right-hand side is staying the same. Alright, now from here I am going to rewrite all of this in terms of sine and cosine. 1 minus the tangent, that's not a Pythagorean identity, and I want to just be able to simplify this fraction, so let's rewrite in terms of sine and cosine and see what we come up with here. So secant squared, that's the same as 1 over cosine squared. And then the denominator we have 1 minus, and then tangent is sine squared over cosine squared. Okay, so we have this complex fraction. Now, one thing that I can do with this is if I want to simplify a complex fraction, if I can take this denominator, combine these two terms together, I'll end up with one fraction in the numerator, one fraction in the denominator, and then I can change that to multiply by the reciprocal. So to combine these two terms together, we do need a common denominator. So I'm going to turn this 1 into cosine squared over cosine squared. So let me just write that all out. So here's our numerator, and then in our denominator we'll have cosine squared over cosine squared. So that was the 1, and then minus sine squared over cosine squared. Okay, now we can combine these together. So we're going to end up with, so here's our numerator, 1 over cosine squared. And then this is going to be divided by cosine squared minus sine squared over cosine squared. So now I was able to turn this complex fraction, so I have one fraction in the numerator, one fraction in the denominator, and now we can turn this into multiplying by the reciprocal. So change this up here. So what we end up with is 1 over cosine squared, and then multiplying by the reciprocal. So we'll take that bottom fraction and we'll flip it. Cosine squared of theta minus sine squared. So multiplying by the reciprocal, we have a cosine squared on top, a cosine squared on bottom. Now I can't cancel out this one because we are subtracting the sine. So this cosine squared of theta is it's stuck with this sine, so we need to keep that there. But we end up with 1 over cosine squared of theta minus sine squared of theta is equal to our side that's staying the same. And we are almost there. So we have the 1 over on both sides, which is what we want. However, it's close, but it's not quite the same as what we have here. On the right hand side, we want to end up with 2 times the cosine. Right now I have 1 cosine. So just comparing those two, let's take our sine squared and let's rewrite this in terms of cosine squared, which we can do with the Pythagorean identity. So sine squared plus cosine, that's the same as 1. So that means the sine squared is the same as cosine, or 1 minus the cosine. So I'm going to take sine squared, and I'll substitute in 1 minus cosine squared, and that's my Pythagorean identity there. And then doing that, hopefully we can see we'll distribute this negative. This will turn into plus cosine squared, and that'll turn into minus 1. So we end up with 1 over 2 cosine squared of theta minus 1, which is what we're looking for. Great. Now with both these examples, definitely not the only ways you can approach this, but I was just using some of the methods that we've talked about: Pythagorean identities, rewriting things in terms of sine and cosine, and then in this case we are also using a lot of our algebraic operations just to simplify fractions or combine like terms.